All right. So turn the quizzes in, finish up at 1 o'clock. 1, 6, 1, 7. Wednesday, finish up chapter 1. You get the review sheet for the chapter 1 test. On Monday, it's review. Wednesday next week, chapter 1 homework is due. Make sure you follow the directions on the assignment sheet. Make sure you show up with it ready to turn in at 10 o'clock. We'll start the test as soon as the homework has been turned in. And I will go through the stacks of the homework to make sure things are filled out correctly. So if there's somebody who doesn't fill it out correctly, it stalls the process of starting the test. And when I say that, I mean, did you fill out did you score all your homework? Did you write them up? Did you add up your total score out of 70 points possible? No decimals, please. If you think you deserve 8.1, just give yourself a 9. Okay. It's all laid out on the assignment page, on the assignment sheet. If you need an assignment sheet, it's posted in the announcements. I have extras to give you. Just ask me after class. Okay. It has to be in order, staple, assignment page on the front, not paper clip, not in the binder. Don't show up trying to put it all together. Show up with it ready to go, because if we wait on you, people are going to be just waiting on you, because the test is going to end at 11:50. Once the homework is collected and I've checked it, gone through, thumbed through it, name is on it, first and last name. Okay, because we know how many daisies are in here. So just daisy who? Oh. So have all that ready to go. And that'll be next Wednesday. Next Wednesday. Is anybody walk in late? Do you have a quiz? It's done until 10:30 to get Lisa. Here's our makeup of graphing any kind of function. There's always going to be an A in front of whatever function you might have. And right now we're dealing with absolute value, square roots, and quadratics and radicals, square roots. There's square roots here. Absolute values, quadratics, square roots. V-shape for absolute value, parabolas for quadratics. And the radical sign looks just like the square root, looks just like the graph itself. A, whether it's positive or negative, dictates whether it opens up if it's positive, or flips it across, or reflection across the x-axis if it's negative. If you have a negative value of A in front of your function, a negative changes positives to negatives, a negative changes negatives to positives. So it's a reflection across the x-axis. It flips it. H, If there's something in a parentheses with the x coordinate, that's a horizontal shift. So x minus h. It has to be in the parentheses with the x. If you're going to move the graph left or right, you're messing with the x coordinate, which means it has to be in a parentheses with the x. If it's not in parentheses with the x, there's no h, there's no horizontal shift. So it would have to be included inside the parentheses with the x or inside the function with the x. There's a built-in negative, x minus h. So you're going to do the opposite of what you see. H is the opposite sign. So when we see x minus 3, h is positive 3. It's a horizontal shift, 3 to the right. We see minus 3, we're going 3 to the right. X plus 4. H is negative 4 because it's the opposite sign. H is negative 4. Horizontal shift, 4 to the left. Square root x plus 5. We see a positive 5, so h is a negative 5. Horizontal shift, 5 to the left. Inside, or excuse me, after the function has happened, after you've done the absolute value or the square root, then you have a vertical shift. That's where k lives. After the function has happened, taking place. And k is the vertical shift. We're adding or subtracting something from the old y coordinates. If we add something, the whole graph is going to shift up. If we subtract something, the whole graph is going to shift down. It's a plus k. We change the sign on h because there's a negative in front. It's the opposite sign when you take out the h. K has a plus in front, so you're going to keep the sign for k, for the vertical shift. You're going to keep the sign. So when we see absolute value of x minus 2, I see a minus 2 afterwards, so k is a negative 2. Keep the sign. It's the absolute value graph, but it's been shifted down 2 units. X squared, and then a plus 3. So this is after the square has happened, so that's the k coordinate. It's been shifted up because it's a plus, up 3 units. Square root of x, and then a minus 5, that's not under the radical with the x, it's after the radical. So k is negative 5, it's this graph, but everything's been shifted down 5. K is a negative 5. You put h and k together. That's where we start the graph. You know what the parent functions look like. You just need to know where you're going to put it. It's the same graph no matter what. Where are we going to put it? And is it upside down or right side up? So h and k are going to be right in front of your nodes. And you have to be able to figure out what they are. So we're going to do 15. Then we'll go back to 90. Here's what I should have done. I'm actually going to change it. My fault. Are you trying to get with it? Yeah, I'm going to grab the parent function on that column. Yeah, Okay. So what I did was I got rid of all the extra junk. Square root, radical sign, parent function. It starts at the origin 0, 0, and it basically does this. Now, what would we actually like to plot? Pick nice numbers. On the other graphs, you pick anything you want. X squared, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. They all work out nicely. But square roots, not every number has a nice square root. 0, 0 is good. 1, 1 is nice. But don't pick 2. If you let x equal 2, then y is the square root of 2. Square root of 2 is approximately 1.414. We don't want to plot decimals. What's a nice perfect square? 4. If I were to pick a number, I would pick 4. Let x equal 4. We get y equals square root 4. We get a 2. So when 4 goes in, we get a 2. Not to scale. 4, 2. And then the next perfect square would be 9. 4, 5, 6, 7, 8, 9. We'll plug in 9, we get 3. Because y equals square root 9, we get y equals 3. So when 9 goes in, we get 3. Other than that, everything else is an ugly decimal, and I don't want to plot ugly decimals. So when you're dealing with square roots, just picking random numbers is not the way to go. A square root looks just like a radical sign. Just like that. Now, if you can just figure out how it's shifted or flipped or changed, you just need to do those things to it and not plug in any numbers. So that's the parent graph. That's the parent function. Plain old simple, bare bones, y equals square root x. And then we do this to it. Get used to this. What does a equal? Negative 1. Negative 1 times square root of x. And then just for the heck of it, get used to it. What does h equal? What does k equal? Inside, there's nothing being done to x. H is 0. There's nothing added or subtracted after the square root. K is 0. So the first point that you can plot, the HK coordinate for a radical sign, for a square root, would be at 0, 0. Okay? So that's not going to change. It didn't shift left or right. It didn't shift up or down. It stays at 0, 0. The only thing that did happen, because A is a negative 1, it's going to flip. Normally, it goes up to the right. When it flips, it's going to go down to the right. It's a reflection across the x-axis. We're not changing the value of x at all. The x's don't change. What's changing is there's a negative in front of the old y value. So that's still 0, 0. When we plug in 1, okay, we got positive 1. So now when we plug in 1, it's going to flip down below. We're going to get negative 1. When we plug in 4, we got positive 2. So when we plug in 4, it's going to flip down below, and we're going to get negative 2. It's going to flip down below. And when we plug in 9, we got positive 3. So now when we plug in 9, f of 9 would be negative, and then square root 9. So f of 9 is equal to negative square root 9 3. 9 goes in, negative 3 comes out. Let's do this. Answer reflects the vertical reflection across the x-axis. Everything that was positive is shown just negative. You don't need to plot a bunch of numbers. You just need to know that this can slip down here. Good news on your test, you're not graphing it by hand, it's multiple choice. So you need to know what that negative in front would do to it, if that's one of your problems. If there's no negative in front of it, like right here, I don't see this. Negative square root x plus 3. So it's an upside down one, isn't it? Well, process of elimination, which one can you eliminate? D. Cannot be D, because D is going up, not down. So now we have D is done, and we just have to figure out A, the graph has been shifted to the left. B has been shifted up, and C has been shifted to the right. Got to figure out from there, well, which one is it? You just go through process of elimination. What is the information you've been given? That's all. So just try not to overthink. But just easy to remove. But you take it apart by looking at what you have. And it really does help to identify what the pieces are. G of X, what is A? 1. 1 times square root of x plus 1. So since it's a positive 1, we know it's going to go up to the right. And then inside, there is something in there with the x. So that means we have an h. So what is this h in? Negative 1. When you take out h, it's always the opposite sign. Because h inside the function with x has a built-in negative. So you got to take out the opposite sign when you have an h. It's always a built-in negative, so you take out the opposite sign. So this is a horizontal shift. Because I see plus 1, it's going to go 1 to the left. And then is there anything after the square root? No. So k is a 0. So the first point for this square root, the hk, is at negative 1, 0. negative 1, 0. Everything is shifting 1 to the left. Negative 1, 0, so that's going to negative 1 here. 1, 1 is going to shift 1 to the left, so now it's going to be at 0, 1. This used to be at 4. It's going to go 1 to the left, so it's going to be here at 3 now. 3, 2. 9 is going to go 1 to the left, so it's going to be here at 8. 8, 3. Every one of these went 1 to the left on the x-axis. And you can check, plug in 3. What's 3 plus 1? What's the square root of 4? So when I put 3 in for x, I get the 2 for y. When I put 8 in for x, 8 plus 1 is 9, or 9 is 3. When I put 8 in for x, I get 3 for y. And the goal is to not plug anything in. To recognize that h is negative 1, so everybody's just going to the left one step. It's just a jump to the left. It's a puzzle. You got to take apart the pieces. So when you're trying to do those things to the h function, identify what you have. What's the a? A is positive 1. So since it's positive 1, it's going to still go up to the right. Inside here, h is positive 2, and k is positive 1. So the first point, the graph is going to start at 2, 1 instead of 0, 0. So instead of starting at 0, 0 going this way, it's going to start at 2, 1. It's going to start here and go that way. So everything got moved 2 to the right. So this point right here goes 2 to the right. If I plug in 2, 2 minus 2 is 0, square root of 0 is 0, and then add 1. It went 2 to the right, and then we add 1. 2 minus 2 is 0, square root of 0 is 0, plus 1. So when I plug in 2, I get 1. This used to be at 1, so when I plug in 1, that point's going to go 2 to the right, so it's going to be a 3, and up 1. This point's going to go from 1, 1, it's going to go 2 to the right, and then up 1. So if I'm at 1, and I go to 2 to the right, I'll be at 3. And if this is 1, and I go up 1, I'll be at 2. I should be at 3, 2. So it used to be at 1. Plug in 3. 3 minus 2, 1. Square root of 1, 1. 1 plus 1, 2. This point used to be at 4, 2. And it's going to go 2 to the right. What's 2 to the right if I'm at 4? 6. So when I put in 6, okay, 2 to the right and up 1. It used to be 2, so now it should be a 3. 6 minus 2 is 4. Square root of 4 is 2. 2 plus 1 is 3. You can't put 0 in anymore. There's no graph over here at all, because if you try to use 0, 0 minus 2 square root of the negative. It doesn't work. You can't plug in one. 1 minus 2 is negative 1. You can't plug in 1 because you can square root of the negative. This graph, everything is shifted over because the domain now starts at 2 to infinity. Because you can't plug in those values because you get negatives inside the square roots. Bottom line is, what's H? What's K? Up or down, left and right. One piece at a time. How does each one change? Now, homework, they want you to verify it on a graphing calculator. On a test, you can use your graphing calculator and you can graph it and see which one, A, B, C, or D, which one it is. Remember, if you don't know how to punch stuff into your graphing calculator, the graphing calculator is never wrong, ever. It will always graph what you punch in. So unless you're punching the right information in, that's where the trouble happens. You can't show up on the day of a test and expect to know how to use it. Make sure you know how to use it before you get here. Parentheses. Okay, going back to 19. So you're given, this is the graph of f of x. Erase. And we're supposed to make the new picture. Now, I want to point this out. When you get your review sheet on Wednesday, question 11 and 12 are exactly what we're doing right here. Here is the graph of f of x. On this grid, you're supposed to graph g of x. G of x is equal to negative f of x plus 3 minus 2. So you're supposed to negative f of x plus 3 minus 2 to that and draw the picture. Over here, here's the graph of f of x. You want to graph g of x equals negative f of x minus 1 minus 2. So we want a negative f of x minus 1 minus 2 to this and draw that picture. In order pairs. So what I'm showing you is exactly how you want to approach ordered pair. That's why those are the two. So what's A? Positive 1. So there's no flip. A is equal to just 1. No flip. What's H? Positive 2. So there's a horizontal shift 2 to the right. What's K? 0. So it's this picture, everything is going to get shifted 2 to the right. Everything's going to get shifted 2 to the right. We could just do it right now. We could if we want. But what that means is, I'm going to use the ordered pairs. You take these old x coordinates, and you're going to add 2, and that's going to be our new x coordinate. This x coordinate has to be 0 plus 2 because h is a positive 2. 0 plus 2 because h is equal to positive 2. So 2. The y coordinate is still going to be negative 1 because the y value is not changed at all. There's no negative or anything in front of the f of x, and there's no plus or minus a k value. The only thing that's changing is the x coordinate. We're shifting it 2 to the right. It's going to keep the same y coordinate. So this is now going to be at 2, -1. So it's this x coordinate, and we're going to shift it to the right 2 units. So it's now going to be at 3. And the y coordinate's going to still be 0. This is 3. We're going to take this x, and we're going to shift it to the right 2 units. So we're going to add 2. It's going to now be at 5. This y coordinate is still 1. So we're at 5, 1. This old x is going to get shifted to the right 2 units. So this is now 6. The y coordinate doesn't change. It was at 16. You take a straight edge. Please have a straight edge. That got shifted to the right, to the right, to the right, to the right. The reason why I'm putting up the ordered pairs is because it's not going to be that simple. So get used to working with ordered pairs. Why not get used to working with ordered pairs with a nice simple problem? I know you're going to want to do this. That's a 0, 0 minus 2, so that's a negative. H is the opposite side. Opposite side. I'll just live RC. Instead of -2, we get +2. So here, every single time, let me start with A. What is A? 1. So there's no flip, there's no stretch or anything. What is H? -3. So there's a horizontal shift, 3 to the left. All of this is going to go 3 to the left. And then what's the K after the function? 0. So it's a horizontal shift, 3 to the left. So it's going to be this one, and we're going to have to subtract 3. So that's going to be happening at -3. And we're still going to get the y value of 1. When we plug in 1, it's going to be 1 and then -3. So we would plug in -2. Plug in -2, we get 0. And here it would be 3 minus 3. So we'd have to plug in 0 and then we get 1. And then we would plug in 4 minus 3, we plug in 1, and we get a 2. Each one of these points have been shifted 3 to the left. 1, 2, 3 to the left. 1, 2, 3 to the left. 1, 2, 3 to the left. And because you identify that H is -3. So it's this old X minus 3. This old X minus 3, because that's what H is. This old X4 minus 3, because that's what H is. So that would give you your new X4. The only thing that f of X plus 3 is telling us is that H is -3. And it's a horizontal shift to the left 3 units. All right, what is A? So it's a 2. All right, that's a little different now. I'll come back to that. What is H? Good, 0. H is 0 and K is 0. And that's that you like that because now there's no horizontal shift, there's no vertical shift. That's okay. We're not moving left or right, we're not moving up or down. But A is 2. All that means is this. Since there's no horizontal shift, the X that we're going to use for our new graph is the exact same X that we're plugging in here. This X is the same as that X. Before, that whole X plus 3, the X changed, so we had a different X here because it was X plus 3 in the given problem. Obviously, this is going to, when it was f of X plus 3, then what we plug in here has to be different than that. There's going to be a difference when you do something to it. But since this is just f of X, and that's going to be exactly the same as the old X, because nothing happened to the X's. We did nothing to the X's. We left X alone. Restraining order. No, that's what he has. Okay. What we did do is we did something to the old Y value. The new Y value is 2 times, oops. The new Y value is equal to 2 times f of 0. So the new Y value is 2 times, what's the old f of 0? -1. What's 2 times -1? So the new Y value is -2. All it does is double the old Y answers. This new Y coordinate is twice the old Y coordinate. It's twice the old Y values. Y is equal to 2 times f of 0, 2 times f of 1. F of 1 is 0, so 2 times 0 is 0. F of 3, so it's 2 times f of 3. F of 3 is 1, so 2 times the old Y value. 2 times 1, that's a 2. This new Y value is 2 times f of 4. F of 4 is 2. So this is 2 times that old Y value, which is 4. 0, -2. 1, 0, 3, 2, 4, 4. When you put that 2 in front of the function, it stretches the y values. It stretches them. The x's are still in the same place, but now they're twice as tall than before. You've doubled them. So now they're stretched a little higher than before. If you put a 1/2, you're going to crush them a little. You're going to scrunch them up. Okay? So when you double the value or triple it, it would be 3 times higher. You're not moving it left or right. You're not, flipping it upside down or anything. You're not shifting it up or down. You're just stretching it when you put a number other than 1 here. Okay? And stretch. Okay. I will not do F2. Something. We're not going to do a negative in front of the X, but we're going to talk about it. What does this do? What does y equal negative f of x do to the old f of x? Come on, somebody be brave. Let's sit where? What? Across the x-axis. So if I did negative f of x, this would flip up, this would be here, this would flip down, this would flip down, and it would look like that. What was negative is now positive. When you flip 0, it's still 0. This positive is now negative, that positive is now negative. Everything is reflected across the y-axis, the x-axis. If I put a negative in front of the old y values, it's reflection across the x. What do you think is going to happen if I put a negative in front of the x's? It's going to reflect across the y. If you put a negative in front of the y's, it reflects it across the x-axis, up and down. If you put a negative in front of your x's, then it's going to reflect it left and right across the y value. Because now when you want to actually let x equal 2, just the x, and I plug it in, I get y equal to f of, there's a negative, I actually end up taking negative 2. I'm using 2 though. But when I actually punch it into the equation, it goes in as a negative 2 because this negative is right here. If I say let x equal my x a negative 9, then when I go to plug it in, I get y equal to f of negative, and then here comes my negative 9, and it actually evaluates y equals f of positive 9. It does the opposite. I'm getting an answer when x is negative 9, but it's going to evaluate the function for positive 9. So it's going to give me the answer to the other side just on this side. I know it'll sound really confusing. Let's just put it at that. Left and right, switch. When you put a negative in front of the x, it's a reflection across the y-axis. put a negative in front of the y's, you get a reflection across the x. So opposite of x. Well, the opposite of 0 is still 0. The opposite of x. So I would use -1. The opposite of x. So I would have to use -3. The opposite of this x. So I'm going to use -4. What I'm going to get out of my graph is f of these values, these ordered pairs. So if I plug in 0, f of the opposite of 0, that's just f of 0, and f of 0 is still -1. So that's not going to change. Now I'm going to plug in -1. I'm plugging in -1 into here. There's a negative already, and then I'm plugging in my -1. So now I have y equals f of +1. When I plug in 1, I get 0. My -1 gives me 0. So that point is now over here. I can't plug -3 into the original function because -3 doesn't work in the original function. The only thing I get in the original function is +3. So to make it work, I have to start here, and I get 1. So when I use my -3, I get over here. That point is reflected over to here. The left is reflected to the right. If it's a positive x, it's now flipped over here to the negative side. The negative x is flipped over to the right. And this would go to 2. So -4 would give us 2. So if you put a negative in front of the x, it's a horizontal reflection across the y-axis. The x's change signs. And that's what that means. Change the sign of your x's. All of these x's change the signs. The y's don't change at all. Nothing's being done to the y coordinate. We're just changing the sign of the x's. Yeah. That's one. Again, I'm not going to ask you one like this. Who knows? One half x. So a is +1. So it's not going to flip. Inside it's just 1/2 times x. So there's no horizontal flip.
H is 0, so there's no horizontal shift. K is 0, so there's no vertical shift. What's happening is before you take the value of the function, you take half of x. You take half of x. Now, here's the problem. We only have y values. We only know what happens if we plug in 0. We only know y equals f of x. F of 0 is -1. F of 1 is 0. F of 3 is 1. F of 4 is 2. This is what we know. F of 0 equals -1. F of 1 is equal to 0. F of 3 is equal to 1. F of 4 is equal to a 2. Here's the good news. Is there anything times the function? On the outside times? Any negatives that flip? No. Is there anything added to the y, those functions? The y value is not going to change at all. It's the same y value. What's being altered is the x form. 1/2 x. It does not mean 1/2 of this x. Doesn't mean that. You know what I mean? Twice this x. Kind of like your brain has to work backwards. Which should be fine because that's what you usually do anyway, right? I should ask your parents. I only know f of 4. So, does that mean I go 1/2 of 4 and I use 2? No, because if I try to plug in 2, then I'm taking f of 1. That's this up here. So what would I have to plug in if I actually want 4? What would make half of what is 4? 8. I want whatever this is right here. Okay. 1/2 of that question mark needs to equal the 4 so I can get the 2. So half of what number equals a 4? 1/2 of 8. So this has to be an 8. One half of what number is going to give me this 3 right here, or the 3 that I can use? Half of what number? This one, I would have to plug in 6. Watch. Y equals f of 1/2. I plug in 8. So I'm going to get y equals f of half of 8. It's now f of 4. F of 4, 2. So when I plug in 8, I get 2. Y equals f of 1/2 of 6. If I take half of 6, I get 1/2 of 6, I get f of 3. F of 3 is 1. So when I plug in 6, I get 1. So if it says half of x, I got to double it before I plug it in. Because I only have coordinates for these x's. So I have to start over here with twice as big to get to that 4. Twice as big to get to that 3. Twice 1 would be a 2, and twice 0 is still 0. So 0, -1 doesn't move. This is now 2, 0. This is going to be a 6, 1. And that's going to be a 8, 2. I stretched it this way.
So is that 1/2? Is there the 8?
No, because h is x minus
H. So H is a horizontal shift left to right based upon being added or subtracted from X. When you get to Wednesday's lecture in trig, and we start changing the period of a sine curve, where it's usually 2 pi, and we change it to half a pi or 4 pi, that's what we're doing. We're stretching it, making it longer, or we're shrinking it, making it shorter. That multiple in front of the X is what does that. Because what's happening is it's basically taking twice as long for that graph to happen. The numbers have to be twice as big to get the same values because they're going in half as slow or happening half as fast. We need twice as long to feel that happen. If it was a 2, then it would be switched this way, and they would happen twice as fast.
So it's opposite.
But I'm not going to ask that of. We are 75. So 7375, it says in 7476, determine which equations may be represented by the graph shown. There may be more than one correct answer. So you're supposed to look at the picture, and there are 6 choices. And you have to decide which ones, maybe one, maybe more than one, might represent the picture. So 73 or 75, which one do you want to see? I heard both, so 73, who votes 73? 1, 2, all right, raise your hand higher so I can count. Let's do this right. 73. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11 on 73. 75. Okay, looks like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So 75 words. No. Here, another same way. Parabola, so definitely we're looking at f of x is equal to a parentheses x minus h squared and plus k. Is that a picture of a parabola going up or down? Up. So since it's going up, a better be positive, better be greater than 0. Definitely. And is it a horizontal shift, left or right? Going to the right. So since it's a horizontal shift to the right, h would have to be a positive, which means we would see something like an x minus a number inside the parentheses. If it's going to the right, okay, in the parentheses, we would see x minus because we would do the opposite direction. We would do the opposite direction. If we saw, like for right here, x plus 2, this h is equal to negative 2. X minus 1, that h is positive 1. This one is going to the right 1 unit. This one's going to the left 2 units. Because that's a plus inside. So that's a negative 2. And that's a minus 1 inside. So that's a positive 1. Opposite sign for the h's. So this better be an x minus inside the parentheses. Well, is there a vertical shift up or down? And it's what? So k better be equal to a negative. So now we look at A. It's a positive in front.
X minus a number squared, and then a minus a number. A is looking good. Okay. Positive plus 4. If that's a plus 4, then here H is -4. That means it should have been shifted to the left, not the. Okay. -2 minus 4. Okay. So negative on the inside, shifting to the right, down 4, down 4. C is looking good. Plus 2 would shift it to the left. We're not going to that. And then E. You see how it's written backwards? We could just do this. Negative X minus 2 squared, and then go plus 4 afterwards. But regardless, look, there's a negative in front of the square, isn't there? That means this picture would be an upside down graph. And it's not upside down. Same thing here. This can be rewritten as negative X plus 2 squared and then plus 4. And that negative means that would be upside down. Yeah.
Now, A and C both look good. And technically, I don't like this question, but for them, because they don't label anything, they don't give us any numbers. Both are fine if you wrote them down. Which one is better? Which one do you think is better?
I would say C is better because 2 to the left and then down 4. It looks like the horizontal shift is shorter than the vertical shift, just in terms of proportion. But because it's not the scale, it don't give us anything to look at. Who knows?
Both are fine. Both could be the answer. And that's kind of what they're after. Which ones could be the answer? They both could be.
That's all you do. You don't have to draw it. You just need to analyze it. Analyze it.
No, I would put both. I would put both. Both would work. And then 74, 76.
I know 76 is a cubic next to the third, but you know, this. I made one of the choices.
Which one?
I won't ask you one like 76 since I told you I wouldn't. One.
46.
All right, 76 is where you raise your hand. Okay, so it's 1, 2, 3, 3. 74 is everybody else.
So obviously square root.
A square root X minus an H and a plus K is what we're building off of. Is it right side up or upside down? Looks like it's been flipped, so A would equal a negative. Is there a horizontal shift left or right with this thing? Because normally it's here. It's been flipped upside down, but did it shift left or right? No, it's still on the y-axis. H is 0. It's been shifted up or down? Down. So K is negative. So process of elimination. A has to be a negative. That looks good. K has to be a negative. Nothing inside the radical. A is looking good. And again, they wrote it like this. This is negative square root X and a minus 4. It's exactly the same as A. It's exactly the same function. They just rewrote it. So B is good. So far. F of X though. So let's rearrange it. negative, square root, negative x, and then a minus 1. Now, is there a switch across the y-axis? Has it been flipped this way? No. So it's not. This one, again, there's no flip across the y-axis. If there was a flip across the y-axis, it would have to go the other way. Another one right there. Can't be that one. And how come it can't be f?
Flip above the axis.
Right. It's positive square root x. This one would go up, not down. So since these are the same functions anyway, the answer is A and or B. Definitely is both. All right.
That's 1.6.
So brush off with your 1.3 quiz and substituting, then simplify. Here comes 1.6 and 1.7, substituting and simplifying. But we're going to be dealing with operations with functions. Adding, subtracting, multiplying, dividing with functions. First things first, notation. The sum. Sum means addition. So f plus g, function f plus function g of the variable x. This is the function notation. Means, please do yourself a huge favor. Rewrite it. First thing you should do is rewrite it. It means you take function f of x and you add function g of x to it. You're just going to add the functions together. Add them. So now x was equal to 2x plus 1. G of x is equal to x squared plus 2x minus 1. So f plus g of x. So that would be rewrite. That means function f of x plus function g of x. And so that's going to be f plus g of x means you take function f of x, 2x plus 1, and we're going to add function g of x, x squared plus 2x minus 1. Now, addition is not going to hurt you. When you add, signs don't change. Add a negative, it's just subtraction. You add a positive, it's just addition. It's not going to mess with you. What messes with you is when you subtract. When you subtract, you definitely need parentheses. But how do you remember to put parentheses when you absolutely have to? It doesn't hurt to just put it when you don't have to. It's this function f of x plus that function g of x. You do your order of operations. Inside, nothing I can do there, so it's just 2x plus 1. Inside, nothing I can do there, so I'm going to drop the parentheses. I'm going to add this x squared and a 2x and a minus 1 to it. Now, if I didn't put the parentheses, that would be fine. It wouldn't hurt it. Again, where it hurts, subtraction. You'll see in the next one. So now you simplify. F plus g of x is equal to, combine your like terms. Start with the biggest power, x squared. And then we have 2x and then 2x, that's 4x. And then we have a positive 1 and a negative 1, they cancel out. So f plus g of x is x squared plus 4x. Okay. The difference f minus g, function f minus function g of the variable x means f of x minus g of x. Subtract the function. But this is how it can be written, and this is what it looks like when you rewrite it, when you expand it. F minus g of x is equal to function f of x minus function g of x. So function f of x is 2x plus 1 minus x squared plus 2x minus 1. Now, if you think you can get away without the parentheses, that's going to be a wrong answer. I'm going to leave that right there. I'm going to do it the wrong way. If I don't put parentheses, then this is what I end up with. F minus g of x. So I gather up my like terms. I have a negative x squared. And then a 2x and a positive 2x is a positive 4x. And a 1 minus 1 is a 0. They cancel out. So I get negative x squared plus 4x. That's the wrong answer. Okay. Need to do is it's f of x. So 2x plus 1, that function f of x, minus g of x, parentheses, x squared plus 2x minus 1. F minus g of x is equal to, in this parentheses, nothing we can simplify, 2x plus 1. You can't simplify x squared plus 2x minus 1. So now to subtract, you distribute the negative. Minus x squared is now negative x squared. Minus 2x is now negative 2x. Minus negative 1 is now positive 1. So f minus g of x is equal to negative x squared. Positive 2x minus 2x cancels out. That's a 0. And then 1 plus 1 is plus 2. You see, it can't be both. Obviously. Now I'll show you one. Oh, pick a number between 7 and 9. Good, 8. Okay, over here. F plus G of 8 is 8 squared plus 4 times 8. So F plus G of 8 is equal to 64 plus 32. So F plus G of 8 is equal to 96. Also, F plus G of 8 would be F of 8 plus G of 8. That's what this means. F plus G of anything is just add the two functions together with that number plugged in. So I can put 8 into the first one, 2 times 8, and then plus 1. And then plug 8 into this one, 8 squared plus 2 times 8 minus 1. So that's 16 plus 1, that's 17 plus. That's 64 plus 16 minus 1. So that's equal to 80 minus 1, that's 79. 17 plus 79, 96. No matter how you do it, gotta be six. Next. F minus G of 8. So if I do it this way, F minus 8 minus G of 8. So F minus G of 8 would be F of 8. So that's 2 times 8 plus 1 minus 8 squared plus 2 times 8 minus 1. Now where did F of answer? F of 8 is 17. Minus G of 8, 79. So F of 8 minus G of 8 is negative, what is that, 62? Yeah, no. Negative 12? Negative 62, right? Are we okay with it? Then one of these, or both of them, if they both work, they should both give you negative 62. F minus G of 8, negative 8 squared plus 2. The negative is not being squared. Negative 64 plus 2, negative 62. Okay, this one works. F minus G, 8, negative 8 squared plus 4 times 8, negative 64 plus 32. I don't think so. Why did I get it wrong? What did I do wrong when I did this? No what? No. Parentheses. When I got this answer, I didn't put parentheses when I subtracted that. If I use parentheses all the time, I'll use parentheses when I absolutely have to have them. I know you know how to subtract. Question is, will you do it correctly? You've been warned over and over and over again. Product, multiplication. So it's pretty much, I don't want to say C spot run, but it's no shade Sherlock. When you see addition, you can add them together. When you see subtraction, you subtract one from the other. Multiplication, you multiply them together. So the notation F times G of X product F times G, function F times function G of the variable X is just F of X times G of X. Multiply them together. So when we rewrite it, this would be function F of X times function G of X. So function F times G of X would be 2x plus 1, this one times G of X, which is X squared plus 2x minus 1. Okay. Remember when, I was showing off up here, I had like 3x minus 5 squared. Now we just go, all right, that is equal to 9x squared minus 30x plus 25. You guys, your special product rules? We don't have one for that. This is just 3x minus 5 times itself. We're squaring something. This is not a square. This is a binomial, 2 terms, times a trinomial, 3 terms. So you distribute. This is where FOIL fails. We run out of letters in the word FOIL. FOIL is great here. First times first, outside, outside, inside, inside, last times last. Just enough letters. We run out of letters in the word FOIL to do that. So, distribute. Each term in this parentheses multiplies with one at a time, each term in the other. F times G. Distribute 2x. 2x times x squared. That is 2x to the third. Positive 2x times 2x. That's positive 4x to the second. Positive 2x times negative 1. That's a negative 2x. We've distributed 2x to each term in the other parentheses. 2x is done. Now you distribute the second one. We distribute 1 to each one. Positive 1 times x squared is positive 1x squared. Positive 1 times the 2x is a positive 2x. Positive 1 times negative 1 is a negative 1. Multiplication is just distribution. 1 at a time. Draw the rainbows, they might help. Raise some skill, it's fine. Don't make that. Mind like her. F times G of X would be gather up all the biggest powers first. The biggest power is x to the third. We got 2 of those x cubes. And then we go looking for x squares. Got a couple of those. 4x squared and a 1x squared is 5x squareds. X to the first. Negative 2x, positive 2x. Cancel that. That's 0. Then a minus 1. Okay. And then the quotient. Guess what quotient is going to be? You get the root word quotient. What operation? I mean, I'm not hearing so bad.
They're good. Fractions. Ratio, fraction.
So we have F plus G, F minus G, F times G, F over G. So it looks like this, F over G of X. Function F over G of X means just take F of X, divide by G of X. Now there is a restriction here. G of X cannot equal 0 because you can't divide by 0. Always that restriction. So here we're given what is F over G of X. That means the rewrite F of X over G of X. So then the numerator is 2x plus 1, and the denominator x squared plus 2x minus 1. As far as you can go, unless you know how to reduce that, it's not going to reduce by But that's all you do is rewrite it like that. If we said, what is F over G of, let's go with, 2. So that would be F of 2 over G of 2. So the numerator, 2 times 2 plus 1, and the denominator, 2 squared plus 2 times 2 minus 1. So 4 plus 1, 4 plus 4, minus 1. So we get 5 over 7. It's not F over G times 2, F over G of 2. So F of 2 over G of 2. Okay, we're supposed to graph on number 10, h of x. And h of x is equal to f of x plus g. So obviously, if I'm going to graph a picture of h of x, I need ordered pairs. And that's how you got to think ordered pairs. Here's the x values we have to work with. For g, this is g right here. We have 3 ordered pairs, we have 3 points. And for f, we have the same x values, but we have 3 points. So we're only going to plot people. We have something at -3. We have something at -1. And we have something with x is positive 2. So I can get 3 ordered pairs for h at -3, at a 1, -1, and at a 2. H of -3 is equal to f of -3 plus g of -3. G at -3, g is 1. F at -3, f is -3. F of -3 is -3 plus g of -3 is 1. So h of -3 is -2. Which is -1. I want an order pair for h, but I'm plugging in -1. So that would be f of -1 plus g of -1. On the f function, when you plug -1 into the f function, what's the y value? 0. So f of -1 is 0. And when you plug -1 into the g function, what's that y value? 2. So that's plus 2. So h of -1 is 0 plus 2. H of 2 would be f of 2 plus g of 2. So at 2, when x is a 2, we're over here now. F of 2. When 2 goes into the f function, what does f equal? 2 plus what is g equal? -1. 2 minus 1 is equal to 1. So when 2 goes in, we get 1. So the graph of h, now that I have my order pairs, we have something at -3, 2. We have -1, 2. And we have 2, 1. That's all you do. But it boils down to this. H of x is defined as f plus g of x. So h of x is add those y values up for those individual x values. You find the ordered pairs, you plot them, and connect them up. Simple. One at a time. Okay. Okay, you've already, hopefully you've already recognized my pattern. I've been about a halfway through 1/6, which means I need to finish 1/6 and 1/7. I'll still give you the review sheet, I think. We'll see. I might need to do some alterations to it. But the test is going to be on the 7th. Is that the Monday? The test will be Monday the 7th. Basically push back a day. The review will be Wednesday. We'll finish up on the 30th. Like that. Okay. All right. My goal is to have your quizzes back to you on Wednesday, but no problem.